Everyone. I am Batul Madani from the American University of Sharjah, and I'm here to present to you the research paper entitled by Predicting Consumer Purchasing Decisions in the Online Food Delivery Industry. So before presenting, I would like to introduce the authors of this paper. I am a PhD candidate and a graduate teaching assistant. My research interests cover wireless technologies, machine learning, decision-making, drones, logistics, and optimization. The co-author of this the co-author of this paper is Professor Hussam Shraida. He holds a dual PhD degree in industrial engineering and operation research, and his research interests include statistical process optimization and smart data analytics. So in this presentation, we will be covering the followings. We have the introduction, problem statement, purpose, the data set description, analysis, and finally, the conclusion and recommendations. So starting with the introduction, the Internet's fast evolving technology has given limitless opportunities for businesses and customer relationships. It has boosted specifically the online food services by allowing consumers to search, compare the provided services, and select companies with the highest service performance. The food delivery industry has experienced a lot of transformations, moving from restaurant to consumer delivery to platform to consumer delivery, in which in 2013 this business of a platform to consumer came, and many specialized delivery players have provided logistic support for the restaurants. So this new business model provides customers with the ability to compare, for example, menus, check reviews, and place many orders from different restaurants at the same time. This industry has grown by 25% between the year of 2015 and 2018, and it's expected to grow at a rate of 10.7% by 2023. Worldwide, China leads the way in the market share of this industry, followed by the US and then India. Between 2020 and 2024, the market's revenue is expected to grow at an annual rate of 7.5%, resulting in a market volume of around $183 million by the year of 2024. This indicates the rapid increase in the online food delivery market, which intensifies the competition between companies to gain dominance among others and increases the need to determine the key success factors that are critical to the online food delivery providers. So they need to gain insights and reviews from customers to capture a larger segment of the market share. Besides, the decision of whether or not to make a purchase is a complex process impacted by those critical factors that the online food delivery providers need to understand. So the reasoning behind that requires the evaluation of multiple measures such as, for example, the timing of the delivery, the performance of the tracking system, the quality of the packaging, and many others. This requires the collection of customer data about their evaluation of the performance of the online food delivery companies in terms of different aspects and whether they will purchase in the future or not, in the context of how did they rate the attributes of that affect the performance of the delivery providers. One possible way of exploiting the data of customers' purchasing decision is via machine learning techniques to construct basically accurate prediction models. For maintaining customer relationships, accurate predictions of the customer's activity and the future or anticipate the purchasing decisions which are critical. Therefore, machine learning techniques are used to anticipate those decisions in the context of the online food delivery industry, and this is accomplished through the use of a data set about customer purchasing experiences which covers a variety of characteristics. After that, a comparison of the three production models will be provided in order to determine which model is the most suitable one and provides the best performance in terms of the production accuracy. So to predict whether the customers will purchase again or not, we have a data set obtained from the open source database Kaggle that is used. And this obtained data set was collected from 388 consumers in Bangalore, India. And it has a different variables. Basically, we have 55 variables consisting of the demographic variables and other categorical variables about rating the performance of the delivery provider. Besides, we have a binary variable which includes which covers whether the customer will purchase in the future or not. So here we have the list of attributes. Okay, we have some of the attributes which were removed from the study because they are out of the scope of our research. So we performed an exploratory data analysis just to understand the data set and draw some insights. For example, the mean average of the respondents were 25 years, and the mix of respondents were fairly balanced, with males contributing to 57.2. And in terms of the marital status, singles have a comparatively large presence, followed by the married, and most of the respondents were students, then followed by the employees. And we have other also insights that we got from this EDA. Okay, so 3 production models we used. We have the decision tree, the CARD decision tree, and the C45 decision tree, the random forest, and finally the rule-based classifier. They were all compared based on their performance. And in all of these 3 models, the training data covers 75% of the data, while the remaining 25% is assigned to test the data. The method for data training is a cross-validation with 10 faults, and afterwards we compared them based on the production accuracy, which was derived from the confusion matrix that summarizes the classifier classification performance. And in order to do that, we used R software to build the models. Now, one of the used decision trees, as I mentioned, is the CARD decision tree, which is known for its simple interpretation and inherent logic. And after implementing it, it was found that ease and convenience of ordering, as well as the ordering saving time elements, are of the highest importance. After that, the confusion matrices of the training and the testing data were evaluated. The accuracy of the training data was 87%, while in the testing data, the production model has shown a production accuracy of 84%, which implies that the cart is performing somehow well. Now, the second decision tree is the C45, that is known for its ability to work with discrete and continuous data, as well as handling incomplete data. So after implementing it, the contributing attributes to the purchasing decision are shown here in the figure. For example, such as the ease and convenience and good taste. So if you want to interpret one of those, we could say that if the ordering ease and convenience is rated less than 2, or less than or equal to 2, and the importance of the good taste was rated above 2, then the consumer will not purchase with a probability of 90%. So as we have done in the previous method, the accuracy of the training data is 91%, while in the testing data, the accuracy was 92%, which is much better than the CARD decision tree. Now, the third one is the random forest. Okay, and when we applied it to our problem, it outperforms the C45 decision tree on the training data with an accuracy of 94%, However, its performance on the test data is less, with with an accuracy percentage of 90.6. Okay. Lastly, we have the rule-based classifier, which is employed in the class prediction method to give the rules a rating. So when we implemented it, we were able to draw conclusions such as if the age of the consumer is less than or equal to 25, then they are expected to purchase again. If, for example, the ease and convenience and the time saving are rated above 2, and it's unaffordable is rated less or equal to 3, then the consumer will decide to purchase. Now, when compared with the other production models used, it performs less than the random forest model, in which the accuracy on the training data is 91, and while on the testing is 87.5. So when we compare the 4 models, we see that the C45 outperforms the other 3 production models based on the test data. Okay, so this study was intended to understand the behavior of the customers toward the purchasing decision using a list of attributes. So we have relied on the production models in order to achieve that. Also, past research has considered the implementation of production models on purchasing decisions. However, a limited number of studies have incorporated the use of them in the industry of online food delivery. Among the other algorithms, we can see that the C45 has outperformed them all. Okay, so as recommendations and limitation of the study, the ultimate goal of the study was basically just to illustrate the power of the machine learning techniques and their ability in obtaining accurate decisions. Since the C45 decision tree has outperformed the other models, we may be able to improve its performance further. For instance, and test it on a different data set. For instance, it was only used for a small data set with around 400 customers. So its suitability for mining massive data set must be examined. Also, we may be able to improve these traditional production models by enhancing their accuracy and the time that is taken to derive the classifications and the outcome. So thank you all for listening.